Projectile Motion Series, M&M Quiz 2178. Welcome to hecanhelp.com. Points P and Q are at the same vertical height with respect to point A. The vertical velocity vector component at P is 19.6 meters per second. Question: what is the vertical velocity vector component at point Q? Assume no air resistance and constant acceleration. Assume change in vertical position, delta y, from P to Q equal to 0. So is it A, B, C, or D? So based on the equation of the kinematics, we have V final y is equal to V initial y plus acceleration along the vertical times time. The final velocity along the vertical, we are going from P to Q. So we want to know the final velocity at point Q. We know the velocity at the initial point, point P, and that is 19.6 meters per second. Acceleration along the vertical is negative 9.8. Positive x is defined as to the right. Positive y is defined as vertically up. So we don't know what time is, but to get the time, we can use change in y is equal to 0. Between points P and Q, change in y is equal to 0. And what is the expression for change in y? The displacement along the vertical. V initial y times time plus 1/2 acceleration along the vertical times time squared. Change in y as we go from P to Q is 0. V initial y at point P, what is the vertical component of the velocity vector? It is 19.6. Time we don't know. 1/2 acceleration along the vertical is negative 9.8 times time squared. We have time and time squared, so we can divide throughout by time t, and we get 0 equals 19.6 minus 4.9. 9.8 divided by 2 is 4.9, and because of the negative it's minus 4.9, and t squared just becomes t, from which you get t is equal to 19.6 divided by 4.9, and that is 4 seconds. So time to go from P to Q is 4 seconds. Now you can go back to V final y is equal to V initial y plus acceleration along the vertical times time. V initial y is 19.6. Acceleration along the vertical is negative 9.8. Time is 4. And so what do we get? It is negative 19.6 meters per second. So first you solve for time, and then use that time and get the velocity along the vertical at point Q, and that is negative 19.6. So if at point P the velocity, the vertical velocity vector component is positive 19.6, at the same height, point Q, we have velocity negative 19.6 meters per second along the vertical. So one is vertically up and the other one is vertically down, provided points P and Q are at the same vertical height. And this is George Mathew signing off. Good luck.